Y'all, it's 8:35. We're gonna get started. So, just some quick announcements. Tomorrow, A1 is due at 11:59. I was able to get the script to work, so I extended it by one deadline or one day. So earlier on today, I was trying to sync CMS with Student Center, and then I accidentally removed all students from CMS. And so if you submitted your A1 with the text file before today, please submit it again because your submission got deleted. But it's still in the GitHub. That's why we use GitHub in the first place. So just resubmit that text file, and you should be good to go. So partner matching forms are due tonight at 11:59 p.m. So if you do have a partner and want to pair up with someone, or if you are looking for a partner, please fill that out. All of that should be linked in an ed discussion post. Mentorship forms, I've extended it to Wednesday at 11:59, so after Wednesday's lecture. So the mentorship form is just basically you get to bother one of the course staff about anything, text them about like iOS course, or I don't know, ask them for discrete help or something, something like that. So the ad deadline is also this Wednesday. So please, if you want to take this for credit, make sure you enroll in Student Center. And if you do plan on dropping the course, then please shoot us an email. That way we can remove you from the CMS. All right, are there any questions? Yes.
Where can we find the mentorship form?
Yeah, so if you check the ed discussion post, there should be, it's in there somewhere. Okay. So just a quick recap of last lecture. We went over a lot about Swift, a lot of Swift basics. The key takeaway is the optional section. I know we kind of rushed it a little because we were out of time, but hopefully A1 kind of helped y'all understand optionals a bit. So, key takeaway, don't ever force unwrap an optional unless you know for sure that optional is not holding nil. I was going to show a demo about an app that will crash if you force unwrap an optional, but I didn't have time to do it. But just make sure you don't force unwrap an optional because it will crash. And then you want to use string interpolation to combine variables and constants with the strings. You want to do that over using concatenation because it's a lot more efficient and you don't have to cast the variable. All right, any questions? All right, so today we're going to get started with classes. How many of you here are in CS 1110 right now? So at least half, maybe more than half. So the thing with classes is Richie and I try to make the lecture very similar to what you will be learning in CS 1110. I don't know if y'all have learned classes yet, but the stuff that we are teaching today will help you with CS 1110 as well because we try to make it very similar. So this will be a very helpful lecture. Okay, Richie's going to teach y'all classes now.
Okay, so yeah, today we're jumping right into the core of iOS development, which is UIKit. And before we do that, we need to sort of cover what classes are, and I'm going to provide like a basic overview of how classes work and how they specifically work in UIKit. So a class is like in any other language, if you've done any sort of programming before, a class is essentially a custom type that encapsulates data. However, in Swift, they're a little more intuitive as they are a sort of flexible construct that sort of is the building block of all iOS development. So you could essentially think of a class as a blueprint for an object. And from this blueprint, you could create or instantiate multiple objects, each of which contains properties and functions that are associated with it. So within this class, you would specify properties that store values, as well as functions that sort of define the functionality and establish the behavior of these objects. And furthermore, you also need to establish an initializer, which initializes all stored properties in the object. So what is a property? We're going to go into detail about what a property is. So with that, we have an example of a class and an object. So this folder here, if you see on the top right, this is sort of the representation that you would see in 1110 for an object. It is an object folder. As you can see, it is of class student. So in this student class, there are three different properties. We have name, major, and age. As you can see here, each of those properties has an associated type and a value with it. So these objects are all sort of instantiated from this class. So they're all built upon this class blueprint, and they all share these same attributes, but they can have different properties. Sorry, I'm mixing up the word attribute and property, but property is the word we use in this class, but if you take in 1110 or you're about to learn it in 1110, the word that they will be using is attribute. So they're interchangeable, but in iOS development, we use the word property. So as I mentioned earlier, you can have multiple objects from the same class. So here are an example of 3 different student objects that are all of the student class. Each of them have the same properties, so name, major, and age. However, they all possess different values for it. So Vin has the name Vin, and we all have our respective ages. And keep in mind, the types are consistent as well among all properties. But since these are all from the student class, they will all possess the same properties as well as the same types associated with them. So we're going to sort of shift gears into a demo, and Vin is going to demo how to create a class.
Yeah, so I went ahead and created a playground. If you don't know how to do that, you can open Xcode, and then if you go to File, New, and then Playground, you can create a new playground. So I'm going to give y'all like a couple of seconds to do that. Okay, so what I'm going to do is create or convert that student example into actual Swift code. So to create a class in Swift, we use this class keyword followed by the name of the class. So in that example that Richie showed us, we used the student class, or we created a student. And then in Swift, we use curly brackets. Okay, so I created a class called student. Now, each student has... Turn that off. Okay, there you go. Can y'all see back there? Okay, so this student class has these properties that Richie mentioned earlier. One of them was the name, age, and then the major. So this student object will have a name, and I'm going to use a var here. Its type will be a string. It will also have a major, which is also a string. And then I'm going to make the age an int. Okay, so these are our properties which describe the student object. And so now Xcode is giving me an error. It's saying that this student class does not have any initializer. So the issue here is that when we instantiate this object, when we create this object, Swift needs to know how to do that. In order to do that, we have to call this initializer. So in CS 1110, you have a constructor, and then you also have this init function. That init function is basically the equivalent to an initializer in Swift. So it allows you to create this object. So to create that initializer, I use the init keyword, and then what I'm going to do is let it autofill for me. So if I hit enter, it autofills that for you. So what I did here was basically this init function takes in 3 arguments. These are the 3 parameters. And so I could have called this whatever I want, but here we called it name. And because we call this name, then we need to use self right before this name here. So what does self mean, right? Self basically represents this object. And so basically self.name corresponds to the property name, not the parameter name. So by doing self.name, it's saying, hey, this argument that you pass into this parameter name, assign that to the property name of this object. Okay, so this is the initializer function. Now Swift calls this initializer function whenever you create the object. So creating the object in Swift is similar to that in Python. And so to do that, I'm gonna save it to some variable. So let me represent me as a student. So I can say let Vin be equal to a student. Now notice how we're using capital letter here. So classes should start with a capital letter. So when I'm instantiating this object, I should also use a capital letter. And so I'm going to let it autofill. So now these three arguments that I'm going to pass into this initializer, it's going to be my name, which is Vin, major InfoSci, and the age, I am 20 years old. Okay, so what I did here was create a class representing a student, define an initializer for it, and then create an object for it in which this code calls the initializer. And now, because this object is a student, I can access its properties by simply doing vin dot and the name of the property. So you can see here that Xcode automatically shows you which properties you can access. For example, I could do major. Now, if I hit this play button, it might take a couple seconds. Yeah, as y'all may have noticed from A1, the Xcode is very slow. Apple just decided not to, optimize it, but yeah. Let's give it a couple more seconds. Oh my goodness. Okay, honestly, we're just gonna move on. But anyways, if I call this right here, it would print out my major right here, which is InfoSci. Okay, so now Richie is going to cover something more useful when it comes to app development.
Okay, so what we had earlier was the student class, but let's say suppose you wanted to create a variant of that class. So let's say we wanted to create like a Cornell student. Here we have different colleges, but in our original class, we don't really have anything that represents that. So how do we sort of create this new class that we want? We wouldn't exactly just reduplicate it, copy and paste, and then add the field there. We could do that, but that's not how we're supposed to do it. That's not good convention because you're repeating code. So what we can use here is a subclass. So rather than repeating the code and copying and creating a entirely new class from scratch, we can sort of create a new subclass of our student class. So this is the class. If we create a subclass of student, it would inherit all properties and functions from the superclass. So inheritance means that whatever subclass you define and whatever superclass you specify, that subclass will possess all properties and functions from that superclass. However, the one thing you do need to do is that when you create the initializer for that subclass function, you need to specify to call the super initializer, so a super.init, meaning that you would call the initializer from the superclass. So let's say we had a subclass called Cornell student that was a subclass of our student class. In this case, you would need to call super.init in our initializer for the Cornell student in order to initialize the properties of, name, age, and major. So those would be initialized after calling super.init. So this is super helpful in iOS development because rather than sort of defining new classes over and over again, you can sort of build new views, build new classes based on existing ones, so you don't have to reuse, so you don't have to duplicate code. And this saves a lot of time and it saves a lot of code duplication. So yeah, so one of the things that will be very helpful later on when we go into iOS development. And then Vin's gonna do a demo on subclass as well.
Yeah, so hopefully this thing ran. Okay, so yeah, so vin.major is InfoSci because I created an object and passed it to this initializer, the string InfoSci. And so now what I'm going to do now is create a subclass of student. So what kind of students can we have? For example, we can have an engineering student. So I use class again because a subclass is still a class. And then I call that class, let's say, engineering students. And now to make it a subclass of a superclass, you use a colon followed by the name of the superclass. In this case, it's students. So I pass the student. Okay. So now, automatically, if I create an object of engineering student, it will inherit all of the properties that I've defined in the student class, because this is a subclass of student. But there are some properties that you want to make unique to this subclass. So for example, what makes an engineering student unique? I don't know, does shower is a Boolean. Okay, so this describes an engineering student, and it's unique to an engineering student, not for all students though. So I create that property, and now it also needs an initializer as well because it is a class. So if I do init, so the autofill only includes this does shower property, but remember this is a subclass of student, and so I also want to initialize the other properties as well. And so what I can do in this initializer is add in all of these properties. So I'm gonna do name is a string, major is a string, age is an int, and then does shower is a Boolean. And instead of doing self.name, self.major, self.age is equal to these properties, what I can do is just simply call the superclass's initializer and allow it to do it for me. In CS 11.10, you're going to be doing this a lot. So I'm going to teach y'all beforehand. So to do that, you do super.init. So I'm calling the superclass's initializer, and then I'm passing in name, major, and age. Just these properties, because these properties are defined in the superclass. So with that being said, let me create an engineering student. So Archit just joined in, so he's an engineering student, so I'm gonna do Archit. So to create an object, I remember the capital letter because it is a class. So engineering student, so his name is Archit, his major is CS, I think he's 20 years old, not sure. Does shower, false. Okay, so now let me try to do something, all right? Let me try to get Archit's name. So will this print out Archit? Can I get a show of hands if you think it'll show Archit by doing archit.name? Okay, let me try that. Hopefully it runs quicker this time. Yes. So now Archit's name works. What about Archit.does shower? Will that also work? Let's try that. Yes, it does. So Archit does not shower. So this is good. This one's also good. Now earlier I created Vin, which is a student. And remember, this is of the parent class, not of the subclass. So what happens if I do Vin.does shower? Do y'all think that will work? No, because Vin is a student, not an engineering student. So as you can see, Xcode gives me an error. All right, does that make sense? Are there any questions? All right, so moving on. Why are subclasses important? As Richie mentioned before, in app development, in UIKit specifically, we use classes and subclasses to represent our views. So what is UIKit? Well, for my favorite friend, ChatGPT, UIKit is a framework for building GUIs in applications designed for Apple's various platforms, and it provides a wide range of tools and components to create user interfaces for applications. In other words, it's a framework that allows you to build the UI for our iOS apps. So what is UIKit? Again, it's a library that provides classes that represents different kinds of views. For example, if you want to create a label in your app, you would have a class called UILabel provided by UIKit. And then if you want to actually create that view, you would instantiate that object to create a label. Same thing with a button, you would use a UI button. And there are millions of other classes out there representing different views. And now, how do we modify these views, right? Let's say we have a label. How do you want to change its color? How do you want to change its text? Now remember, these views are also classes. And how do we modify a class object? We do that by modifying its properties. And so this UI label class, similar to how this engineering student class has this property, it also has a property called, for example, color, that allows you to change its color. So Richie is now going to demo how to actually create your first iOS application. Do you want me to demo the cloning? I'll do that.
Yeah.
Okay. Yeah, so if y'all go to the course website, inside of this UIKit lecture, I'm going to zoom it in a little. You can clone this repository that I created for y'all. So I copy that. close out of this. Okay. So to open terminal, command space is a shortcut. Type in terminal. What I'm gonna do is I'm gonna put this in my desktop. But to clone it, you do git clone, paste that in, click enter. So now I cloned that repository, and now it's on my desktop right here. I'm gonna open that up and then open the Lecture 2 Xcode project. Are there any questions? Okay. Yeah, so if you go inside of the website and then click on this UIKit plus AutoLayout, it'll have it right here. You might have to refresh to like reset your cache. Okay. Okay.
Okay, so does anyone need more time setting up the file? I can give you guys a little more time if you need. Is everyone good? Okay. So when you open up this file, you'll sort of see before we go to any of the files, you'll sort of see this setup. So what you actually want to do is you want to go to View Controller. We'll actually go into more depth on what this sort of represents and sort of more on how View Controllers play into everything. But for now, sort of just treat this as like your first screen that pops up when you run your app. So this is our View Controller. So first, we're going to try to set up a basic label that has our name on it. So since we covered classes today, one of the important aspects of UIKit is that it has multiple UI classes. So first, we're going to create a constant that is, let's say, a UI label. So we're going to call it name label. And it's going to be a UI label. So we're calling the constructor for a UI label object. So UI label is the class that we're using, and it is a subclass of a general class, which is UI view. So UI label has its own properties, and it is basically just a label that represents any text that you want to display on your app. So to actually create that label, you would set it to a constant, in this case is name label, and you would call the constructor UI label as shown here. So before we do anything else with the label, we actually want to set the background color of our view. Otherwise, our view would just be straight up black. You wouldn't see anything. So we actually want to do view.background color is equal to UI color.white. So in this line, we're setting the background color of our main view to be white. So if you see here, view represents the main view on our view controller. So in this first page, our view is the main view that represents essentially the bounds of your app. So what we're doing here is we're changing the background color. We're accessing that property, and we're changing it to white, which is UI color.white. That is another class that sort of has that object, which is the color white. So now that we have the background color as white, we want to sort of change the properties of our label. So if we wanted to change the text of the label, you can see that we can autofill it as well here. We can do name label.text, and we can just put our name here. So if you see that, we're essentially changing, again, we're going back into the class from before, and we're changing the attribute text to our name here. So there's also other attributes like font. And then in this case, we can just use .system font. This is another sort of class. It's called UI font specifically. And then there's a function called .system font, which sort of returns a font of a specific size. So in this case, we want to give size 24. So after we do that, we also want to change the color of our label. So we can do color, .text color. And we can sort of use the same class as before with UI color.black in this case, because we want our text to pop out on our view. So what we've done so far is that we've created the UI label. We've instantiated it with the constructor here, UI label. There is no initializer that contains parameters because so the UI label constructor does not have any base parameters in it. So we set the attributes in the view.didLoad. So essentially what view.didLoad does is that once Once the screen hierarchy loads onto your screen, this function will run and essentially set up all of the properties of our background and our label. So if you want to run this code right now, you can click Command R, or you can click this top run button right here, and it'll pull up our simulator that you might have seen during the assignment 1, but we weren't really using it. So you see we have the iPhone simulator here. Again, it might take a while your first time to run, but yeah, there's nothing much you can do about that. So hopefully... So it seems like our view is loaded, but it seems like we're having an issue. So the label we just defined isn't really showing up for some reason. Even though we've sort of specified all the text, the color, how we want it to look, it's still not really showing up on our screen for some reason. And the reason for that is because creating UI is not only just setting up the views and setting up their properties. It's also, we haven't really specified where we want to put our view. So that is what we need to do right now, is specify where we want to position our view so that it can be displayed on the screen like that. So that's where we go into our next section, which is, where's the, that is where we go into our next section, which is AutoLayout. So AutoLayout is a constraint-based organization system, allowing for adaptive UI, meaning the UI adapts to the screens of different sizes and orientations. So this is the tool that we use to position our views. Merely setting the properties and creating our views is not enough to sort of display them on the screen. We also need to position them and specify where we want our view to be. And there's many different ways that we can sort of do this, but in this course, we'll mainly be using AutoLayout and specifically NSLayout. This method is usually, since it is relational based, you sort of position your views in relation to the outer views and the views around it. It's less error prone that way. So we're going to go back into our view here, and then sort of position our view now. We see before that our view is created, but we don't exactly see it. So to do this, we first need to add our view to the main view. So we need to add our name label to the main view on the screen here. Otherwise, right now it's not even on the view. So first thing we need to do is actually add the subview name label to our main screen view here. So, and then what we want to do is we want to do NSLayout constraint.activate, and then we do name label dot top anchor dot constraint is equal to view dot safe area label. So if you see here, we're essentially constraining the top anchor. Okay, so essentially what we're doing here is, we're constraining the top anchor of the name label to the top anchor of the safe area layout of our view. So we go to our lecture here. So we constrain views using anchors. So let's say we have the label here called Hello World. There's a top anchor, a left anchor, right anchor, bottom anchor, as well as height anchor and width anchor. So we specify these anchors and constraints to position our view within our screen. So in this case, there's a lot more anchors than this, but in this case, we're just going to be using top anchor. So we're positioning our name labels, top anchor, to the safe area layout guide, which is the top of our view. And then we also need to constrain the center of our view. So name label dot center x anchor is dot constrain is equal to view dot center x anchor. So that way we're also constraining our view to the center x anchor. So we're essentially anchoring our view to the middle x axis of our screen. So it's centered and it's also placed at the top of our screen. So let me just exit out now. You see now we've created our label and then we've established its properties as well as constrained it on our screen. So if you see now, if we run our code again by pressing Command R or this top run button up here, it's going to take a while. It's still not showing for some reason. So it seems like we're still running into another issue here. So another step that we've actually forgotten is that we need to go back and name label dot auto masking constraints. Translate auto masking restraints. You have to set that to false. So the reason being is usually when you're coding in iOS, you can also use storyboard. In this case, we're doing programmatic UIKit. So since we're not using storyboard, we actually want to set auto resizing mask into false in order to use UIKit programmatic constraints. So if you now do that and rerun our code again, you see that the label now appears on the screen. It's constrained to the top anchor. It's also centered at the x-axis. So that is sort of the three-step process that you need to do in order to, one, define a view. You need to set its properties, and you also need to add and constrain that view to your base view controller. So if you do those three steps, you should be able to sort of add your own view to your base screen. So if you notice here that there's quite a bit of code just for adding sort of this one label. There's quite a few lines of code already. And this is just for one UI label, keep in mind, that displays your name. In bigger apps, we'll usually have maybe hundreds, maybe like almost even thousands of different UI elements. So if we want to keep our code clean, one thing we can actually do is sort of abstract all our code into a helper function. So if we cut that out, setup, and define a function called setupLabel, and sort of just paste our code there. And now we can just call setupLabel in our viewDidLoad function. So that way, our viewDidLoad function doesn't get crowded, and we can still sort of have each of our setup sort of constrained into their own functions so that it's more organized and there's less clutter in the viewDidLoad. Because viewDidLoad is sort of what you use to set up all of your views. And this is just the process for one of them. Imagine having a lot more, then later on, we'll sort of have different functions that we'll call in our viewDidLoad so that we don't clutter the viewDidLoad function. Okay. And Vin's going to demo.
So I'm going to demo how to add more views, so not just one UI label. And so one thing that I want to point out is because we could have many properties inside of this view controller, and we don't want other classes to be able to access this. So a common practice that we do is mark these things as private. And what this does is that it prevents other classes from modifying these properties. Same thing with this function. This function is only called within this class. So I mark that as private again to prevent other classes from calling this function. Okay. So for the next part, what I did is I created a branch that you can check out if you're ever behind. So if I go to this folder right here, if you do git checkout, I believe I called it 2-UI or 1-UI label, it'll help you catch up to where we left off. If this happens, then what you want to do is do git stash and then check out that branch. All right. Okay. So now what I'm going to do is, as you can see, this code is a little bit different. My name is here instead of Richie's. So if I run this again, so yeah, my name is here instead of Richie. So in A2, you're going to have to create UI labels as well as UI images, or UI image views. So I'm going to quickly show you how to do that. So remember how we filtered this out into a separate function? So I'm going to do the same thing, but with an image view. So the first step is to always create a property for it. So I'm going to say private let profile image view. Now it's going to be an object of this UI image view class. Okay. So I create this property, and now I want to create some kind of function to kind of set it up. So I'll call it setup profile image, and then declare this function right down here, private func. Let me zoom it in a little. Setup profile image. So now in the view to load, whenever the view loads, it's going to call this function right here. So the property that I had was called profile image view. And remember, we want to modify this view. And so to do that, we have to modify its properties because views are classes. So there's a property called .image that takes in, or its type is a UI image. So I'm going to assign that equal to some UI image, which is also another object. So remember, we create an object by typing its class name, followed by some parentheses. And now, if you look inside of this navigator, if you go to assets, this is how you import your images. So in the assignment handout for A2, I did provide some instructions on how to import assets. So inside of here, I have a picture of me eating a cookie called vin_eating. And now I want to use this image inside of this image view. So to do that, you would do UI image named with quotes the name of the image, which was vin_eating. So now I created the property, I initialized its properties. So now who can tell me what I need to do next to actually get it to display on the screen? Anyone? Yes.
You need to add it to the view, and then you need to constrain it.
Yeah, exactly. So I created a property, but I need to tell Swift where to put it. So I want to put it inside of this main view. So the view has a function called add subview, and because this UI image view is a UI view, I can add that to this view. So I'm gonna add the profile image view. And remember, we want to enable or disable this thing, set it equal to false. So if you do .translates equal to false, it allows us to use programmatic auto layout. So now I want to set up constraint. So ns layout constraints .activate. Press the square brackets, and then now what I'm going to do is constrain it below this other label. So as Richie mentioned before, we can place our views relative to other views. So if I want this image to be below the label, what I could do is say, okay, this profile image view, set its top anchor, constrain that to be equal to the name label's bottom anchor. And now to space it out, you would use a comma followed by constant, which you will pass in a float. So let's say I use 24. So what this does is it constrains the image view's top anchor to the bottom of the label and adds a padding of 24. So it goes down by 24. So if I do comma, I'm going to add another constraint. I'm going to set the image view's center to be equal to, constrain that equal to the view center. But the thing about images is that it doesn't just have a position, it also has a width and a height. So to add a width and a height, you would do profile image view dot width anchor, constrain that equal to a constant this time. So I'll set the height equal to 256, or the width equal to 256, and then do the same thing with the heights. Constrain that equal to 256. So now if I run it this time, hopefully you will see me eating a cookie up here. Okay, so there it is. There's the label. Remember, this right here is a padding of 24 because I added the constant of 24. This width and this height, or this width and height, is 256. And then I center the X anchor. In A2, you will be dealing with image views as well as UI image, but then I also want y'all to be able to use text field as well. So yeah, you'll also be using a UI text field. Okay, are there any questions? Yes.
What is the syntax being
Yeah, so there are actually many ways in which you can activate these constraints. One way to do it would be to call this .activate method provided by this NSLayout constraint class, and basically you provide it an array of constraints that you want to activate. So what I did was provided an array in which I want to activate this constraint, and then I want to activate this constraint, and that's why I have commas to separate it. Does that make sense? Yeah. Good question. All right, are there any other questions? Okay, so now we're going to move on to Kahoot, where we will take attendance. Is the audio? Okay, sadly, I don't know how to set the audio, but there you go. Oh yeah, make sure you use your net ID, by the way, because we have to use that for attendance. Does anyone still need more time? Okay, so let's get started. True or false. If you force unwrap an optional that is holding nil, your app will crash. Yes, true. So make sure you don't ever force unwrap an optional because your app will crash and your users won't like that. Next question. Great job, JL4229, whoever you are.
All right, next question. Which of these following is not a way to unwrap an optional? Very good, very good. So yeah, all of these ways are a way to unwrap an optional, except the unwrap function does not exist unless you define it yourself. You can use an if-let statement, a guard-let statement, or you can force unwrap, but that's usually not recommended.
Yeah, so this was kind of like a trick question. Force unwrap is a way to do it, but because it's forced, it will crash your app. You shouldn't do it, but it still is a way to do it.
Yep, let's look at the leaderboard. Ooh,
no.
Someone's on VL292 is on top. All right, next question.
Next question. We should use string interpolation to combine variables inside of strings. Yes, so true. You want to use string interpolation because it's a lot more efficient and it looks cleaner and you don't have to cast your string or cast your variable to the string type. Similar to f strings in Python. Okay. So let's see who's in the podium. Nice AI 259. VL292. Wait. Oh, okay, wait, never mind.
Who is it?
Nice. ML2735. We might actually think about getting a prize for leaderboard, but we'll think about it.
Just like as an incentive to sort of get these right, there may be a prize if you get the leaderboard at the end of the class.
Yeah. Okay. So just some more logistical questions. Okay. Some more logistical questions. So to-dos. A2, I will release it tonight. It's due a week from now at 11:59. Make sure you complete your partner matching form if you are looking for a partner or you already have a partner and want to be paired. So after today's lecture, you should be able to do part 1, which is basically just creating a profile. I'll just show y'all right now. So if you go to A2 right here, scroll down. Oh, I didn't show the Figma, but there's actually a Figma. Okay, so I do tell y'all how to kind of, in the assignment handout, how to use Figma a little, but there is a guide. And so if you click on high fidelity right here, this is like basically the the finalized version of the design. And so right here, if you turn on dev mode, you can kind of create this. This is your task. You can use me, or you can use yourself or your partner. So what you want to do is if you click on this, you can see the padding or how far away your things are relative to another view. So if I hover over this, the padding was 16. So remember, constant is 16. And center this. These are images. So by the end of today's lecture, you should be able to implement this thing. This right here is a UI button though. It's a little tricky, but in the assignment handout, I do kind of guide y'all how to use UI button a little. But then again, a crucial part of this course is teaching y'all how to Google and learn stuff on your own that isn't always being taught. It's an important developer skill to have. And then after Wednesday's lecture, and so in Wednesday's lecture, we'll teach y'all how to create multiple screens. So you have this view controller and then this other view controller. And so we'll teach you how to navigate between views as well as passing information from this view to the parent view. All right, with that being said, make sure...
So there's like another resource that may be helpful for you. So on our course website, there's actually a UIKit handbook that I've created. So this sort of details all the attributes that each of the UI elements have, and some of them you will be using. It does not have UI button yet, but it may be added later on when we sort of push out more of the assignment. But so far, most of the UI elements you'll be using in A2 will be here, and you have access to those attributes as well as the descriptions for them. So you may find this helpful when you're working through A2.
Yeah, and make sure you fill out your mentorship forms if you want to bother the course staff, and that's due Wednesday. All right, y'all are free to leave.
If you have any questions, feel free to stay behind.